So we're going to look at linear programming. So we'll look at two questions, and then we also try out some questions. Yeah, so these are the type of questions that come in paper 1, the topic linear programming. Like look at this question. So I'll say this is the first question, question 1. Write down the 4 inequalities that define the unshaded region R on the diagram below. So this is a diagram that we have. Now, if you can take a look of this diagram, you're going to discover that this is an X or Y plane. Okay, so this is the whole diagram. So this is the diagram. Then we're going to look for lines that are shaded. So we start looking for lines that are shaded. The first line that I'm going to identify is this one. This is a line, this is a line, this is a line, this is a line, and you discover that it's a solid line and it is cutting at the point where y is equal to 6. That is where it's cutting from. So I'll say the first line is cutting at the point where y is equal to 6. Now the question I'm going to ask is it shading above region R or below region R? Now is it less than R or it is greater than R? So now look at, have you seen, we are looking for this region here which is not shaded, and the region that they've shaded is the region above. So this simply means that our y, the y that we're looking for is less than, because we want the region which is where R is found. So this is the less side. What they've shaded is above, but we're looking for where R is. So R is here, so which is less than. So y is less than. Then if you see that the line is a solid line, you also put equal to. So y is less than or equal to what? 6. So that's the first inequality that we've discovered. Let's look for the second inequality. I can also see a line here that is dotted. This is a dotted line. This one, it's a dotted line. It is passing at this point here. This is a point where it's passing from. Ensure we're checking on these lines on the x or y plane. So this is the y, this is the x. So we're checking on these lines. So it's cutting on this line, and this is the line where x is equal to -1. So it's a line where x is equal to -1. That's why it's cutting. Then we ask ourselves, have you seen why it's shaded? It's shading this side on the negative side, but what we're looking for is this side where there are positives. So where it's shading, it's less, than where we want, it's more. So this simply means that x is greater than. Now since the line is dotted, we're not going to put an equal to. We'll just say x is greater than -1. So this is the second inequality. Now since they need 4, let us proceed. The third inequality is this line here. So we're just looking for the lines which are shaded. This line here, it is passing at this point where x is equal to 4. So this is the point where x is equal to 4. Then what else do we know? It is facing this side, meaning on the greater side, but what we need is this side, which is the less side. We're going backwards. So this simply means x is less than. So this would be x is less than. But since it's a solid line, we're going to put an equal to. So x is less than or equal to 4. So this is the third inequality. Now the fourth inequality is this line here. If you can see it, this is this line here. But this line here, it's kind of a slant one. It's a slant line, so meaning it is not only cutting at one point. If you notice, it is not only cutting at one point, it is cutting at 2 points. So you are going to help me first, before we can find the equation of this line, we find some points which are on that line. So we find some points which are on that line. So the point that I've noticed is this point. I think if you can be able to see it, there is this point here. If I get this point here, want to find the equation, you can pick on any point. So if I pick on this point, it is where it is x is equal to 0, then y is equal to -2. Then another point I'll pick on is where it's cutting the x-axis here. X is 2, so and the other point where x is 2, then y is 0. So I'm going to use these 2 points to find the equation. Now remember what we did in coordinate geometry to find the equation of a line. So we can simply use the formula to find the equation of the line. So that is let us so call this one as our x1, this one as our y1, then this one as our x2, this one as our y2. Then the formula is as follows: y minus y1 must be equal to the gradient, which is y2 minus y1 over x2 minus x1, then open brackets, then inside the brackets now we put x minus x1, like that. Then y minus y1, this becomes y, our y1 is -2, so it's going to be +2 because of that other negative. Then it will be y2, we have y2 minus y1, which is 0 minus, so this becomes 0 minus, then -2, so 0 minus -2, then over our x2 is 2, our x1 is 0, so 2 minus 0, then x minus x1, where x1 is 0. Then this becomes y plus 2 is equal to, we have 0 minus -2, that becomes +2, then 2 minus 0 is 2, then this is x minus 0, which is just the x. Then what we're going to have is that the +2 will cross the cosine, then y will be equal to 2 into 2 is 1, so this becomes x minus 2. Then from there, now this is the equation we formulated. Then the question we're asking ourselves is that what we're looking for, is it greater than or less than? So what we're looking for is up. Have you seen? So we're looking for something that is up, so that is greater than. So I'm going to say y is greater than. Since it's a dotted line, I'm not going to put the equal to, so y is greater than x minus 2. So this is the fourth inequality. So I found all the inequalities. I have found all the inequalities. So therefore I'm going to proceed into the other question. Let's do one more example. Yes, let's do one more example. So if you didn't understand one or two concepts here, you pay attention in the second one. So let's do one more example. So in this example, we have the question which is saying, write, so we're going to say this is our example 2. Write the 4 inequalities that define the unshaded region R on the x or y plane below. So this is the last example we're looking at. Then we'll also look at 2 questions that you can try. So this is what we have here. Okay, so basically what we're going to do is we're looking for lines. So this is where our region is, region R. Then we're looking for lines here. So the first line that I'm able to notice that is shaded is this line here, that is passing here. If you can see this line where y is equal to 3, this is the line here. It's cutting at the point where y is equal to 3, at this point. That's why it's cutting. So now okay, yes, so that is where it's cutting. So it's cutting here where y is equal to 3. This is where the line is passing through, and just that it's not that clear, but the line is a solid line. The line is a solid line, so meaning, so the line is a solid line, so this simply it's cutting at y is equal to 3. Then since the line is solid and we are looking for this part, so what is being shaded is where? So the one which is shaded is the upper part. So the upper part is the one that has been shaded. That is where we are. So the upper part has been shaded. Then we are looking for, yeah, so in fact the line is here. So here I was looking for, the line is this one here. This is the line that is there. So well, this is the line in fact. So these are going like that, like that, like that, like that. So this is where the line is, a solid line. So y is equal to 3, but the part we're looking for where x is down. So meaning this will be less than. So y will be less than. Since it's a solid line, we put an equal to 3. That's the first inequality. The second inequality, I can so let me go down and check. Okay, so it's this line where x is equal to 2. So there's a line that is passing at 2. So it's passing at x is equal to 2, and it's dotted. We're looking for this side, so it's a less side. So I'm going to say x is less than 2 without putting an equal to because it's a dotted line. Then the other line that I'm able to notice there is okay, let's see. So the third line here is this line here. So this line here, which is a slant line. So I can look for some points that are going to help me. So let me pick this point. So let me get this point and I pick this point here so that I can find the equation of this line. So there is one point which is -2, 0. Then there is another point which is 0, 2. So 0, 2. X is 2, or x is 0, y is 2 here. Then I'm going to say this is x1, y1, x2, y2. Then just find the equation of this line. Remember the formula. So we are saying y minus y1 must be equal to the gradient, then x minus x1. So y minus y1, so this will become y minus 0 must be equal to the gradient. Gradient is found by saying y2 minus y1, so it will be 2 minus 0, which is a 2. Then x2 minus x1, so it will be 0 minus -2, which is a 2. So our gradient will be 2 over 2, which is 1, open bracket, x minus x1, so it will be minus, our x1 is -2. So y minus 0 is y. Then this becomes 1 multiplied by x minus -2. This becomes x plus 2. So that is what we have. But is the line dotted or straight? So the line is solid. So the line is solid. What we're going to do is that we are looking for this one down here. Line is solid. So I'm going to say it's a less than. So less than or equal to. So y is less than or equal to x plus 2. So y is less than or equal to x plus 2. That is how that is going like. Now let us see if I will be able to find any other line. We just go down. There is the fourth line. Remember, they asked us to find 4 inequalities. So if we go down, you are seeing that there is the fourth inequality here. So this is another line here which is cutting at -1. It's cutting at this point where y is equal to -1, this point. So that's where it's cutting. So it's cutting at a point. So the fourth inequality is cutting at the point where y is equal to -1. Okay, then is it solid or dotted? So the line is solid, and what we're looking for is there on top. So what we're looking for is on top, so it's supposed to be greater than. So y should be greater than or equal to, because it's a solid line, -1. So you discover that it becomes simpler if a line is just passing at either the x-axis or the y-axis, because you just get the number where it's cutting. But if a line is passing on both the x and the y, then you have to find the equation. Now let me give you some questions to try. So the first question you should try out is the following. So let me show you the diagram properly. Hopefully you'll be able to see. So in the diagram, so this is a diagram, so this is a full diagram. Then the question is, as usual, the question is asking you to find the inequalities that define the unshaded region R. So you write it down. So the inequalities should be 3. So the question is saying you write down 3 inequalities that define the unshaded region R. So how are you going to find those inequalities? So that is what we're supposed to do. So that one is for you to try out. That one is for you to try out. Yeah, so that was the question. And then the other question that you can try out is this question here. So it's like that. So write down 4 inequalities. So this question is asking you to write 4 inequalities. Just let me show you clearly. It's not coming out. Hopefully you're able to see. So hopefully you're able to see the lines where how they are cutting. So this is the diagram. Yes, hopefully you're able to see all the lines here. Yeah, there's a line here, this line that is shaded, this line that is shaded. I can see the third line is here. So they want us to write how many? 4. So let me check where the fourth line is. Okay, the fourth line is there on top. So they're supposed to be 4 inequalities. So based on these 4 inequalities, you are able to find the inequalities. I think this is going to help you and give you a guide.